We learned in the last section about the intermediate value theorem, and what we learned is that if f is continuous, on the interval from a to b, then there's going to exist some value between f of a and f of b. We'll call it FC. So what does this mean? If you look at a graph, then let's just say this is A, this is B. So this just guarantees the existence of some value f of c somewhere in there. So what that means is, let's just say this value is 2 and this value is 7. If f is continuous, then we know that that function's got to equal 5 in between there. Somewhere it's got to equal 5. It's got to equal 4. It's got to equal 3. It's got to equal every value between 2 and 7 somewhere on that interval. And this function can vary. It could drop down to negative infinity. We don't know for sure, but we know one thing for sure, that it's going to have to equal every value between 2 and 7 in between that. So looking at this, we're going to determine if they used the intermediate value theorem appropriately. Now, one of the first things is you have to make sure that f of x is continuous. So looking at this, below is Jasmine's attempt to write formal justification for the fact that h of x equals 3 has a solution somewhere between 1 and 2. So Jasmine's justification is that h of 1 is 0. Okay, that's good. H of 2 is 4. That's good. So 3 is going to exist somewhere between 0 and 4, right? As long as it's continuous. So according to the intermediate value theorem, h of x equals 3 must have a solution for an x value within the interval. But the problem is, did she ever talk about continuity? No. So she never established that h is continuous. So no, we don't know this for a fact because we don't know if it's continuous. I mean, we can check it, but she didn't establish that. Let's look at another one. The table gives selected values of the continuous function g. So they're telling us in this problem that g is continuous, but that means in Min's justification, he also needs to mention whether it's continuous or not. So here's the justification. We want to know, does the function equal negative 50? So yeah, g of 12 is negative 10. G of 21 is negative 100. So negative 50 exists between those two numbers. That's good. And also establish here that it's between. That's good. So according to the intermediate value theorem, g of x equals negative 50 has a solution at some point. Now we know it's continuous, but did he say it's continuous? No. In his justification, he needs to specify that it is continuous. So we're actually going to say once again, Min should have mentioned that g is continuous. Even though it says it in the beginning of the problem, it wasn't put in the justification. Let's take a look at another one. This table, the table gives selected values of the function f. Can we use this to determine if, can we use the intermediate value theorem to say that the equation f of 10 has a solution between 0 and 5? So if we look at 0 and 5, does 10 exist between these? Yes. 10 is between 30, excuse me, and negative 15. But once again, does this establish the continuity in this problem? And no, it doesn't establish continuity since we don't know if the function's continuous or not. This could just be a table of values. It could be discrete. We don't know if it's continuous or not. It needs to be specified. When you run into a table, it needs to say this table represents a continuous function. And that's one of those things that you'll see in the AP test. They'll give you a table and they'll say it's a twice differentiable continuous function. I've seen students stall right there and get confused at the wording, but they're just telling you this because some of the theorems, some of the things we do in the math can't be done unless that is specified. All right, so last one, let h of x equal 2 to the x. Can we use the intermediate value theorem to say that h of x equals 4 on this solution set? So let's go ahead and look at h of 3. So that would equal 2 to the 3, which is 8. And h of 5, which would be 2 to the 5th, which is 32. So does this function equal 4 somewhere in between those? It could, but we don't know for sure. All we know for sure is that this function is going to have all the values between 8 and 32. So no, it's actually not going to equal 4 because 4 is not in between h of 3 and h of 5. So those are really the two things that we're looking for. We're looking, hey, is our value in between the two endpoints? And is it continuous?